The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The METUS Tech Show.
Mitsubishi.
All right, Paul. So we're in Nashville at some point this year, and I'm excited about what we can find for foods in Nashville.
You guys are going to Nashville?
I'm more excited about, let me be honest here, I care less about food. I'm more excited about music.
Yeah.
The music scene. Now, the food just tops it off.
So,
Cherry on top.
We got to stick to the food, though, because I've been to Nashville a few times, and I got to tell you, I think I've mentioned this before, but Hattie B's, a friend of mine told me you got to try Hattie B's. They got that Nashville hot chicken, and you can get it in a sandwich. It's so good. We've talked about Nan's down the street.
Yeah.
They have the honey hot Nashville sandwich. It's basically a Nashville chicken sandwich, and then they drizzle it with honey.
I think we've probably talked about this on like 3 different episodes where we mentioned the Nashville hot chicken sandwich.
That's what Nashville is known for. They're known for Nashville hot chicken. It's basically just really crispy fried chicken, and they put some cayenne and some paprika in there and some other spices in there. And it just was so good. And they're going to drizzle it with honey sometimes, I guess. But so everybody knows about the Nashville hot chicken. Another thing that they're known for is a fried catfish sandwich. I love catfish. It's one of those things, if it's done right, it's very good. And, you'll usually get that on a brioche bun, and you can get coleslaw and pickles and onions and tartar sauce. It's something good. And, of course, I think everybody knows Nashville is one of those barbecue places. We mentioned that a few weeks ago. There's Texas, there's Nashville, there's St. Louis, there's the Carolinas. First place
Kansas
I had burnt ends, Kansas City.
So we got to make time to stop. Definitely stop for barbecue at some point.
One thing I saw
trip.
with Nashville barbecue is they do these sides, and one of them is smoked green beans, which I never had, but I think that sounds pretty interesting. Smoked green beans.
I like the smoked part. It's the green beans part.
You don't like green beans?
I'll eat them because my wife makes me. But come on, they're okay.
I think they're great.
But there's a dish that Nashville is known for that I've never heard of, and it's called a meat and 3. And it's served with a meat of your choosing and a wide selection of vegetarian or non-vegetarian sides. So basically, it's just, I don't know why they would be a meat and 3, but it just sounds like it could just
so it's almost like going for barbecue and picking your sides or getting, your meat and your protein and then whatever sides you want.
Yeah.
So, and I guess they're known for lobster mac and cheese, but which, I don't know. Being from New England, I kind of don't like to get lobster anywhere else.
Right. Fried bologna sandwich.
Now we're talking.
Yeah.
Now that sounds delicious. Bologna is a great food. Like Archie Bunker said, when you eat bologna all day long, you ate bologna.
I love that bologna. Is true. That is true. So do you ever fry bologna at home and make a bologna grilled cheese or something like that?
Yeah. I'll take it and throw in a couple of pieces of, just regular white bread and the kids.
Now the question is do you let the bologna bubble up?
Yes.
Or do you put a slice in it to keep it flat?
No. I like it to bubble up and I like to flip it over.
Because then you get that crispy ring on the outside of the bologna. So if you slice it, it gets, I don't know, there's something about that. It's
I love bologna. When I was in the Army, cue the story music. When I was in the Army, I was at station in Washington, D.C. I was in my 20s. I used to drive home and then drive back, 8 hours, 7 hours, whatever it was. I would take a package of Wonder Bread and I would take all the bread out of the bag. And then I would take out, the butt ends that nobody uses. And I would start making sandwiches. I'd take a piece of bread, 3 slices of bologna, 2 slices of American cheese, another piece of bread, throw it in the bag. So then as I was driving, because I only stop if I have to get gas, and that's when I use the restroom, when I get gas. So I'm driving along. I got my little cooler full of drinks in there, Coke or water, whatever. And then I get hungry. I reach into the bag. I make sure I grab 2 slices. The bologna and cheese were already in there. I don't have to make them on the way.
That reminds me of a trip to Saco River. We did that. And I thought my cousin was a genius for doing that. Took a whole loaf of bread, made all the sandwiches, stuck them back in the bag, and we just,
Yeah, well, it says something if you eat like 15 bologna sandwiches in an 8-hour period. Now they're also for the sweet stuff. Nashville's also known for the goo clusters. That's just the pecan and the marshmallow candies and moon pies. Oh, moon pies are so good.
Pies. You like the mallow cups?
I love mallow cups. Yeah. One of my favorite desserts is banana pudding. I guess they're known for that.
Yeah, I wouldn't have expected that, but it says that like pudding is kind of their thing. They have a pudding festival every year.
Interesting.
They're also known for Kurdish food in Nashville.
Yeah, I bet you Kurdish food is good.
Yeah, so it looks like kebabs. If you like kebabs and like a gyro, looks like a gyro type thing, right?
Yeah.
No, it's like Middle Eastern food. I love stuff like that. I could eat that all day long.
Now, have either of you been to Nashville yet? I think you said you'd been, right?
Yeah, a couple times.
Yeah. What about you, Steve? Have you been to Nashville yet?
No, that's why I'm for the music scene. Being in a band and playing for years, and I have friends that actually moved to Nashville, and some friends that stay in Nashville for like a few months and play the music scene. They're just solo guitarists, and they'll go into different clubs, play a bunch of different clubs on the Strip, and it just sounds like the type of place I want to be.
It was a bit of culture shock when I went, because it really is. I mean, I went on a like kind of a later end of a week in April, and that main street, Broadway, is every single bar has somebody doing live music.
Yeah, and it's
all throughout the week. I mean, it's insane. It's constant music,
and
every
it's multiple floors, from what I understand.
Yes.
They have like rooftop bars and different levels that you can just keep going. There's different.
It's wild. I was like, it was culture shock. You can't get cars down there after 6 o'clock at night. There's no cars going down the road. Everyone's in the road, and it's just every bar you go into, somebody's playing music, and it's like a crazy experience.
Now, I don't remember if it's Nashville or Memphis. It's probably Nashville, but at the airport, they got these famous people guitars on display, like in cases.
Yeah.
I'm pretty sure it's Nashville, though. Yeah, of course, that's what it's known for. It's country music.
Yeah. And there's also a lot of the restaurants I went to were phenomenal. Like you can go to, the whole Broadway's got every country's, famous country singer has a restaurant now. And so, and they keep putting up new ones. I think Morgan Wallen just had a new one go up. But right around the corner from Broadway was this place called Hampton Social. And it's like a really laid back, more like almost like a California vibe, but it's right in the heart of Nashville. It was such a good restaurant, wicked good food, didn't have to wait or anything, really clean, like just modern looking. I loved it. It was a blast.
Country singer John Rich, which I had the pleasure of meeting about 4 or 5 years and playing on stage with him. He has his own club called Redneck Riviera, which is right on the Strip as well.
Yeah.
I like country music. I like the old country. Give me George Jones and Waylon and Willie, Johnny Cash, those guys there. Yep. And one place I'd love to go, not food related, oddly enough, is the Grand Ole Opry, which is the Ryman Auditorium.
Yep.
It's not because I guess that moved, but just the history there. I'd love to go there.
Yeah.
Last couple of times I went, one time it was flooded out. They had some flooding. I was closed. I couldn't go. Then it was closed for renovations. But I haven't been able to go there. But I'd love to see that place. Where Patsy Cline was on stage. All these Hank Williams. I'd love to go there.
We'll be right back. Hey, listeners. If you like the METUS Tech Show, you should check out our YouTube channel called the METUS Training Network. That's METUS Training Network. Head on over to the METUS Training Network for tons of videos and programming made for HVAC professionals just like you. We've got technical training tips, HVAC program updates, and episodes of our new HVAC talk show called The Comfort Zone. Of course, you also get to catch up on more episodes of the METUS Tech Show as well. Head on over to YouTube and subscribe to the METUS Training Network today. Now, back to the METUS Tech Show.
What's also crazy about Nashville, too, that, we've gone to a bunch of places just from traveling, but in Nashville, you go down Broadway, the Bridgestone Arena is right there, like on Broadway, essentially. It's right there. You can see it from walking on Broadway. So that's where the Nashville Predators play. It's where they do concerts, huge stadium. And then you go to the end of Broadway, you look across the river, Tennessee Titans Stadium. It's all right there. It's all like in one big location.
That's awesome.
In other cities, you kind of get out of the way to go to these places, but everything was right there. It was So cool. Such a cool city.
While you're on the Strip, you might as well look for a drink called the Bushwhacker.
Yeah.
So it's a mixture of Bailey's, Kahlua cream, vodka, and dark rum. So
We'll probably have to try.
Sounds good.
sounds like a headache next day. But
Try one of those with a fried bologna sandwich.
I mean, you got to get whiskey at some point too, right? Tennessee whiskey.
Yeah.
I guess they got.
Steve, you're not a whiskey drinker, are you?
I'll drink a little bit.
Yeah.
And it's not too crazy about it.
Yeah, I'm not crazy about whiskey, but they have steak that they marinate in either whiskey or bourbon. I forget which one
Yeah.
it is. That sounds familiar. I could be wrong. But
Yep.
And fruit tea. So if you like sweet tea, I just can't believe that the addiction to sweet tea. And when you go down to Georgia, there's unsweetened tea and sweet tea, and and it's just they love it. I'm not too crazy about it, but yeah, fruit tea.
it's too sweet for me.
Yeah. I have a hard time with that stuff.
But yeah, it sounds like fun. The food looks amazing, and I can't wait for the music scene. But welcome to the METUS Tech Show, everybody. We got Bryn and Paul and myself, Steve.
Hey, folks.
And we're going to talk about something that gets overlooked quite a bit in the field. We're talking static pressure and setting your airflow on our ducted units. We've had episodes before. We might have mentioned it real quick. We had an episode with Scott Fielder on testing and balancing, but we never really got into the nuts and bolts of our equipment, Mitsubishi heat pumps, and we're talking the SVZ, the PEAD, the SEZ, the PAA, any of our ducted units, and this is especially important with our PAA, our A-coil unit, because a lot of this gets overlooked. Contractor may go in, install a ducted unit, and never set any duct static settings.
And this is a problem that's been in our industry for generations. It's a lot of companies, a lot of folks will just show up. They'll two ways. It's either a brand new install, they don't design the ductwork. Well, we'll just, the 24/8 trunk line here, we'll reduce it down. It has to be designed. But what I see, and I used to see a lot more when I was in a van, is going in behind somebody. This doesn't work right, doesn't heat well, doesn't cool well. And they would have existing ductwork from a house built in the 50s or 60s, which was inadequate. Houses, ductwork was designed for heating only at one point. Then they throw an A-coil on there. Well, they throw a furnace, or gas or oil furnace, or a heat pump, or whatever they're going to do. And now the ductwork is just inadequate. So you really can't just throw something in there with existing ductwork and walk away. You got to look at the static pressure. You need a ductulator. You need a manometer. You need some tools.
And in today's day and age, there are a ton of resources as far as tools and information on how to get the measurements you need and do the calculations. You have Measure Quick, you got Testo, you have Field Piece, and so many other brands that all have the manometers and the tools that you need to check static. And it's pretty simple. Yeah. Bryn. So, Bryn, take it away.
Yeah, well, I think, so first what we should do is just start with what external static pressure is. The simplest way to think of static pressure is just resistance to airflow in an HVAC system, right? So how much is that fan having to work to move air through the system? So that's what static pressure, a simple definition of that is. But what we as a group can talk about is what actually affects static pressure, right? So what in an HVAC system affects static pressure? And the first most obvious is just ductwork in general, right? As soon as you put ductwork on that system, you're affecting the static pressure of that equipment. But depending on installation practices or how a homeowner is utilizing their equipment, that can also affect your static pressure. So things like duct sizing, right? We talked about duct type. This is a big one, especially Steve. Steve has like a real pet peeve about the type of duct work that you're using.
Yeah, and in the 80s, when flexible ductwork came out, we would get a 25-foot box of 8-inch flex. And the inventors of flex invented it for one reason. It was to get you from a hard piece of duct to a boot in the ceiling. So that was a 5-foot piece of flex. It was to make an easy connection from a hard piece of duct to a boot in the floor or a boot in the ceiling to a grill.
Wait a minute. They didn't intend you to have a box of flex and stretch it out as far as you can, and then put a piece of hard pipe there and put another box of flex.
Yeah, then that's what ended up happening in the field. Yeah. Everyone in the HVAC, and even if new people to the HVAC industry, looked at this flexible ductwork and said, I can install an HVAC system. All I have to do is buy a bunch of boxes of this stuff and just spaghetti it all over the house. And it just became into the 90s. When I got into the trade in around 1992, I was throwing up in an attic with some duct board at the time. It wasn't even duct work.
That's the worst thing. I hate that stuff.
So it was. I'm 3 years of me being in the trade, crawling in attics was all duct board, and my life was miserable. I was just crawling across an attic with a kitchen knife and some staples and tape and trying to put this system together. And flex, we would run it as far as we could until I was actually told one day, this is not the proper way to use flex.
Right.
So if you are going to use flex, it does affect static, right? And we have something called pressure loss. So many feet of flexible duct, you're going to lose so many CFM.
Yeah.
So use flex as it was intended. Now, I would stay away totally from flex when using any of our low static, concealed ducted units. And because all of that is going to add up and create such a pressure loss that you're not going to have any CFM coming out of that unit.
Right.
All right. So let's get that out of the way. Duct types, hard bends, right? And leakage.
I used to see a lot of that. You'd go up into an attic or in a basement. Somebody would put the ductwork, many years ago, and they put duct tape on it, and which dries up. Duct tape, actually, oddly enough, cannot be used on ducts. But you see these big gaps in there. But now the codes have changed. Our energy requirements have changed. Now you're going to use mastic. You got to seal all the ductwork. So you got to really make it an airtight system. You can't just have a leak. So seal it up.
Yeah. And ultimately, I've been in attics. You see entire systems that are run off of flex duct, and it's not to say that you can't do it properly. It's to say that you have to be aware of what happens when you use all that flex duct. Right? They make 12-inch round flex duct for a reason. Like, people are piping entire systems in this flex duct. The reality is that the proper application for our PEAD or SEZ? And also, are you taking the steps to make sure that you're going to have proper airflow? If you're just throwing a bunch of flex duct on there and walking away from it, that's when you're going to run into problems. It's not to say that flex duct won't work. It's just a matter of, are you setting up that system properly?
It has its proper application.
Right.
And you're not limited to attics. I've seen basements where there's an air handler or a furnace with an A coil on it, and they throw they throw a trunk line on there, and it's just one trunk. It just goes up about 4 feet, and then there's
plenum,
an
right?
octopus. Yeah, just a plenum. That's what I'm looking for.
Yeah.
You got the plenum, and then they just take this take off. It looks like an octopus.
Yep.
It's awful.
Yep.
Right.
Yeah.
And I'm not saying don't use flex. I'm saying use it for what it's intended for.
Right.
And something that people overlook with flex too is there's a process of when you pull that flex out of the box. Mm-hmm. You're supposed to get another person on the other side of that flex and stretch the flex out.
No.
All right. That someone taught me that. It says it right on the box on the instructions. Stretch the flex out because the inside could be kinked, could not be extended the whole way. And when you stretch that flex, that inside coil, it's nice and smooth, and you remove that pressure loss.
Yeah. And just like you were saying, kinks, right? The way we hang flex duct, if you hang it with, you don't have proper support, thing kind of sags, and then you get this really major kink. And again, that's going to affect airflow. Filters is another one, whether they're dirty. The MERV rating on that filter is going to affect static pressure. If you have a MERV 13 as opposed to a MERV 8, right? That's going to be more highly restrictive. So that needs to be accounted for with your static pressures. And then leaks, right? Disconnected boots, not sealing your seams, things like that.
Those and thank goodness that it's now mechanical code to seal ductwork.
Yeah.
All right. Now, when I installed my central AC system about 8 years ago in my home, I'm licensed in that. I didn't even need to be licensed, but as a homeowner, I wanted to install, and I'm in the HVAC trade. I've been in the HVAC trade for 30 years. I wanted to install my own HVAC system. So I went down to the town hall, pulled a permit and everything, and installed my system. And I sealed all my seams and I left them all open. I insulated everything, but left all the seams so the mechanical inspector could come and inspect it. And he showed up and he looked at the job and he says, "Wow, who installed this?" I said, "Oh, I did."
Yeah.
I said, "I basically did everything to my system that I wanted, the mistakes that I've seen over the years, I wanted to make sure I covered all that. And I installed the system the way I wanted to, done correctly and everything." And he said, "Yeah, it looks great. Do me a favor. Give the seams another coat of mastic." And I was like, "Okay."
You had to find something.
You have to find something, but no problem.
Right.
But because I remember I in the install world for 10 years, crawling in attics and running around basements and installing ductwork, we never sealed anything.
No.
Never did.
Nope.
There's a big thing about being in the Northeast too is that like we didn't have a whole lot of AC coils, and so I mean most of what I worked on for the first 4 or 5 years was heating systems where it's just oversized supply ductwork, oversized units, and they're just dumping tons of air into that space. But once you put an AC coil on that thing, everything changes because airflow is much more important on an AC coil than it is for our heating loops. And I always remember, and I bring this up often in class, is I had a heat pump coil put on top of a thermopride oil furnace. And they called in the middle of summer saying none of their registers are blowing cold air. So I got to the job site, took a look, and they had some issues. There was some dripping condensate or whatever on the P-trap. And then I noticed that the return plenum off the top of the furnace, there was nothing on it. It was just a metal grate. So there was no return ductwork in that entire house.
It was just pulling from.
They were in a walk-in basement, and they had the screen door
just
open.
pulling from the basement. Yeah.
Yeah. And so they were wondering, why am I not getting enough airflow? Why is the air not cold? And I'm like, you're not pushing that air through that coil multiple times, right? You condition that air going through the coil more than once. That air has to pass through that coil a couple times and start bringing down that temperature, bring down that humidity. If you're constantly feeding it fresh, humid summer air, you're never going to get that cooling. And so, it's mind-boggling. These are things you come across, especially in the Northeast, where it worked probably great for heat for years that way. As soon as you put an AC coil on there, everything changes because of airflow.
Yeah, definitely.
I had one that was similar, was in the town I live in now, and they said, "Oh, it worked great last year. This year, somebody else installed it." So I go down in the basement, and the door's off the furnace.
Yeah.
I said, okay. So I put the door back on, thinking the homeowner must have come and taken it off. I turned it on. I see, it was a 90% furnace, so I see the blue flames. I'm going upstairs to check the airflow, and I go, yeah, I can hear the blower come on. I feel no air. So I go downstairs, and I'm looking for the filter. I look to the left. There's no return duct. I look to the right. There's no return duct. I look behind it. I literally stood up and I said out loud, I said, "I'm on candid camera. There's got to be a hidden camera here somewhere." So I went up and spoke to the homeowner. I said, "There's no return duct on here." And I found that, the panel off the furnace was, "Oh, yeah, the guy said you have to leave it like that or it won't work." It went off on high limit in the time it took me to figure this out. I said, no, it was just sucking the air from the basement, a dirt basement, natural draft water heater right next to it. It's a disaster. I mean, it could kill somebody.
Right.
And just, okay, yeah. So somebody's got to come put some ductwork on here for you.
Yeah, you would be amazed at how many furnaces get installed and live their life tripping on high limit, and no one knows it.
Yes.
Especially if it's a resets on its own, like the old ones we used.
The manual high
No,
limits.
but the old ones were that little coil, that little helix coil, and it would cycle off the high limit,
and no one knows anything is wrong with the system, and it's that furnace is taking a beating. That heat exchanger is probably going to crack at some point.
But once they switch to the bimetal high limit switches, those things have a certain amount of times they'll open and close, and that's it. Then they stay open.
Exactly.
But that's the thing is air, right? We don't really think about it much as when we think about volume, but there's only so much air you can fit into a space. So if you don't have anywhere for that air to go, you cap out. So you'll feel reduced airflow from those registers because it can't. The air's going to take the path of least resistance. If that air has nowhere to go in that space, it can't move. You have maxed out the amount of air allowed in that space. So again, being in the Northeast, older homes, we didn't worry about it because houses were so leaky for so long, and we just knew the air is going to escape through the windows, through poor insulation, and we can keep feeding that air. Now, totally different game. Insulation, everything's a lot tighter. that air is going to max out in that space, and then we can't put any more air in there.
Now, we talked about running new ductwork. We talked about sealing ductwork. We talked about furnaces, but let's be honest here. Majority of the time, the contractor is retrofitting a home, and they may be using the existing ductwork. Be very careful and know what is in that home for ductwork before you go and install the system. Our variable speed SVZs and all our units are variable speed. They're going to protect themselves. So if you install that system with on ductwork that's undersized, that system is going to, and it has thermistors. They're smart coils, so there's thermistors on the inlet and outlet of the coil measuring refrigerant temp. And if that coil is getting too cold, that fan speed is either going to crank up to try and prevent a freeze up, and their compressor is going to back off. So you could have all kind of humidity issues. You're not removing humidity. You're just underperforming because of ductwork. You know, I don't want to keep telling stories, but my cousin wants me to help him size a furnace for his house. He has an old oil-fired furnace, and all of the takeoffs are 4-inch.
I've seen
and
those
they're
houses.
buried in the ceiling of a finished basement.
Yep.
So I told him, I said, I don't want nothing to do with this job. You better call somebody, and you know, he wants to put a heat pump system in. I says, you can't do that with 4-inch takeoffs. Whoever did that job back in the day,
have them do some mini splits.
and they basically,
that's what a lot of people end up having to do is go ductless.
and they just basically just put these 4-inch hard pipes into the duct without a boot. It was just stuck into the duct 3 or 4 inches.
Wow.
So the airflow is just blowing by.
You don't want anything to do with that.
I don't want anything to do with that install. But like I was saying, the contractors are installing, you may be installing an SVZ air handler on existing ductwork. Measure out that ductwork and make sure that you have the right application. And what a lot of contractors don't realize is that we have static pressure settings on all of our ducted units. So you can adjust that static.
Yeah. So another thing too, even before you get into, you know, necessarily making sure the ductwork is going to work with the equipment is am I picking the right equipment? Right. Because our SEZ, which our pancake unit, our ceiling concealed ducted unit, they don't make up a lot of static pressure. They can't overcome a lot of static pressure. So
they're
make
made
sure,
for a small room.
Yeah. You got to make
office,
sure that your application makes sense.
maybe a couple of bedrooms, and that's it.
Yeah, the SEZs are not designed to go in an attic or a basement and you put a 48-foot trunk line on there and do a whole house. It's just designed for 1 or 2 rooms. We talked about this a couple of weeks ago. You know, I've got a small room. It's too small for a 1-to-1, so I could put a ducted unit, an SEZ in there, and do that room and another
Split
room.
a couple of rooms. Yeah, absolutely.
But that's what it's designed for, 1 or 2 rooms. It's not, I'm not going to do a whole floor or a whole section of a house.
No.
So, Bryn, I've just installed an SVZ, existing or new ductwork.
Sure.
And what is the contractor responsible for? What should he be doing before he leaves that job site?
Yeah, so this goes into just balancing a system, right? And again, I have to give credit to Scott because he gave me this education. And, you know, prior to that, I had a, you know, very surface level understanding. But he's a test and balance guy. So when he kind of
so am I, but I forgot everything. I forgot everything I did back in the I used to know formulas that, you know, So, but no, Scott, he did it for a long time, and he still remembers all of those formulas.
Yeah, and you know that was his primary function. You know, he may not have been putting gauges on equipment, but he was absolutely checking that ductwork to make sure that everything was set up right. For an SVZ, right, depending on the unit, but typically, I'm just going to use a 12,000 BTU for an example. The first things that we need to do when we've got that unit installed, the ductwork is hooked up, is we need to take a total external static pressure. And the other thing that we need to do is we need the install and service manuals to determine 2 things. One thing we need to determine is what is the default static pressure setting on this piece of equipment. So an SVZ 12,000 BTU, the factory default is 0.5 inches of static. So that's what the airflow is set for, 0.5 inches of static. So we get that through the install manual. We also need to know what the design for that system is. So again, with an SVZ 12, the design CFM, meaning at optimal conditions, right? To optimize efficiency, to optimize performance, we want 448 CFM passing through that system. So now that we have that information, we have what the default static pressure setting is, we have what the design CFM is, now it's time to actually make some calculations. So we always want to balance the system using high fan speed. So we need to go to that unit, whether we use the controller, we can use that SWE jumper that's on our PNS series units. We want to put that fan into high speed, and we need to take two measurements, one on our supply side and one on our return side, measuring the airflow rate. So inches of water column, we're going to use a manometer, make a small hole in that ductwork, insert the manometer, get a measurement for that inches of water column. So just as an example, let's say on the supply side, we put our manometer in there. It's showing us 0.26 inches of water column. We go on our return side, we have negative 0.26 inches of water column. One thing that's really important with checking for external static pressure is it is what's called an absolute value, which means that negative that we see.
We're not subtracting that.
Absolutely not. No. So what we're doing is actually just getting rid of that minus sign. That's really just an indicator of the direction of the airflow, right? But it's still showing that resistance. So we get rid of the minus sign. We just add those two numbers together. 0.2 on the supply, negative 0.26. We get rid of the negative. We have 0.46 as our total external static pressure. So now that we have our total external static pressure, we can go to our service manual, and every one of our service manuals has these, is the fan curve charts. So we put fan curve charts in there for every potential external static setting. So with like an SEZ, there are 4 settings that we can set our external static for, as low as 0.02 and I think as high as like 0.1. With the SVZ, we go as low as 0.3, as high as 0.75. And so there are 3 total settings, 0.3, 0.5, and 0.75. Each one of those settings has a fan curve chart. And in that fan curve chart, when you look at it, there will be basically almost looks like a tornado kind of going up on this chart. And you'll see 3 lines going across that tornado. The lowest one is for low speed. The middle one's for medium speed. And then your top line is for high speed.
So 0.3, 0.5, 0.7.
No. So we're leaving, I'll get there. But So you've got low speed, medium speed, high speed. And that's on that fan curve chart. So 3 different charts, they all look exactly the same except for the static setting. So because we know that our default static setting for the SVZ is 0.5, we need to go to the 0.5 inches of static pressure chart. And that fan curve chart, on the y-axis of that chart is the calculated external static pressure, which we took was 0.46. So we go on that y-axis and we find 0.46. Now we work across, going horizontal to where we intersect with that high fan speed. Remember, we tested in high fan speed, so we need to see where we intersect on that high fan speed curve. It's that solid line. It says high right next to it. Wherever we intersect, we look down to the x-axis. The x-axis is your CFM. So remember, our design CFM is 448. For this particular example, if you have 0.46 total external static pressure, that means your CFM is around like 650-ish.
So we're too high.
Way too high, right? Your design is 448. We're at like 650. So what we need to do is slow that fan down. How do we slow the fan down? We need to change that static setting. So instead of 0.5, maybe we try 0.3. Let's see if 0.3 gets us closer to that design CFM. So a couple ways to do that, right? The first way is modes 8 and 10, our function settings. All right, you go to the manual for the indoor unit. It will tell you how to set those function settings based on, what, mode 8 and 10 based on what static you want. So we want to make sure that we get down to that 0.3 in this case to slow down that fan. And then once we've done that, we're going to check again, put the fan back in high speed, take an external supply and return side static pressure, add those together. And like for the sake of example, you do it the second time, and let's say you end up with like 0.17 on your supply side and then negative 0.13 on your return side. We add those together, we get 0.3. We go to the fan curve chart, but now instead of looking at the 0.5 fan curve chart, we want to find the 0.3 fan curve chart. All right, so we'll see it kind of follow a different flow, but we're going to do the same thing. That 0.3 calculated external static, we go up on the y-axis, go across until we intersect that high fan speed, work our way down, and see where we show up on our CFM. Now, if you get a 0.3 external static on that chart, when you look at it, it'll actually be right around that 440 CFM.
So we're right where we want to be.
We're right where we want to be. So this is how we set that fan speed, right? We need to take an actual value, compare it to the chart that the external static is set for, and then make changes based on what our rated CFM is. If our rated CFM is 448 and you've got 600 CFM on your chart, we need to slow the fan down. If we're too low, we need to speed that fan up, and we're going to change those settings using modes 8 and 10, or sometimes it's dip switches, right? We can do it with dip switches on the indoor unit. But that's how we have to balance that system. And the reason why we have to do that, and like this is the biggest part of it, is if you don't do that and you have too much fan speed, we may be able to drive down temperature pretty quick, but what do we not do?
Humidity.
Can't get the humidity out, right? So we're optimizing that fan speed to drop temperature adequately, but also so that we can remove moisture. You don't want a cold, damp space. High fan speed, too high of fan speed can cause that problem. And then conversely, if you don't have enough fan speed, you're going to have comfort issues. The unit's not going to be able to keep up, right? And so what a lot of people do, and I have contractors in all the time say it, well, we just change the evap temperature to lower when we have this issue, right? We have a multi-position air handler homeowner saying it's not keeping up in the middle of the summer. What do? They just lower the evap temp. Well, does that fix the issue? No, of course not, right? We still have an unbalanced system, and a lot of times that's what the issue is. And I can't tell you how many contractors have been in class. I talk to them about make sure you set your static pressure, and in their head they're like, oh, I got to go back to that house because that's probably what's going on.
Right.
It's super common. I mean, I never did it. I very rarely ever paid attention to it. You assume your sales guy or engineer already did this work and knows the ductwork is going to work out. But to do a thorough job, once you have that ductwork hookup, you have to do that at total external static inside your fan.
So I'm a contractor. I just installed an SVZ air handler, and I'm getting ready to check my static pressure.
Yep.
And I'm going to take my if listeners, if you don't know what the SWE jumper is,
yep.
Every indoor unit, ducted indoor unit that we have has a small plastic jumper on these little pins called SWE. So if you move that jumper over, you're essentially taking that system and putting it to its highest speed automatically.
Right.
Yep. Is there another way to put that system into high speed without moving that jumper?
Just a controller, right?
Yeah.
So you can go into your controller. You don't have it calling for anything. You just put it in fan mode and then just maximize that fan speed.
Max your fan speed.
Yeah. All
right. So now I got to take my measurements, and my question is, and I'm sure a lot of people listening are thinking of this as well. I'm drilling a hole on the supply side of my plenum, and I'm inserting my pitot tube on my manometer, whether it's an old school manometer or an electronic manometer. Most likely it's going to be electronic measurement tool. And then I'm taking a static on my return. Am I doing that before the filter, or am I putting the filter into that?
So if it's the factory filter, right? So the filter that comes with our unit, then we
include it.
Yeah, we just take our return, right in the return plenum. The problem comes when you have a third-party filter, right? That has to be included as part of your measurement. So you want to go before that filter to make sure that that's included as part of your static.
And in both cases, a clean filter.
Of course.
Yeah. That's pretty important.
Yep. But I mean, the big thing, and again, I credit Scott for all this, but the big thing is that don't try to balance a system in any mode other than high speed. They have the fan curves for middle and low, but don't go by that. Use your high fan speed to make this calculation, because the reason why you want to do that is when it's 95 degrees, hot and humid in that space, what's your fan speed going to be at, right? It's going to be at that high speed. You're going to be cranking along. We need to make sure that the system's balanced for that high fan speed.
Yeah, our tech support department get bombarded with these calls, and that's why this is an important episode, because this gets overlooked a lot, and a lot of performance issues are due to not setting your static pressure correctly. Now let's talk about the PAA.
Yes.
Because this is, and I hammer this home in M&P class and in the IntelliHeat class. I tell the contractors, you have to set the airflow on the furnace. Now you have a third-party furnace. You have a Train furnace. Maybe it's a Goodman furnace. Maybe it's an older furnace that you're installing a PAA coil on. You cannot walk away from that job without making sure you have at least 350 to 400 CFM per ton.
Right.
Being delivered out of that furnace. Now, how do you change the fan speed on the furnace? Open up the install manual. It may have speed taps,
right?
Just stake on connectors that you're moving to change that fan speed from low to medium high to high. And you're going to have to do the same thing, checking your static pressure, making sure you have the correct amount of airflow, and change that speed tap. Or maybe it's a newer, like a train furnace where it's digital.
Right.
The furnace board will have a push button on it where you're going to cycle through some different selections and to set that static pressure correctly. Yeah. So really important with the PAA coil.
Yeah. And also, just because we're on that topic, because of the way that the IntelliHeat gets installed, we do want to check in different locations. So unlike with, our air handler where we're just checking supply and return, when we require that 350 CFM per ton to the coil. So we actually want to check between, so essentially the top of the furnace before we actually get to that coil. We're actually not going to check after the coil and the ductwork. We're checking airflow to the coil.
In between the A coil and your heat exchanger.
Yeah. So we're going to check there and then our return to get that total external static, because what matters to us more than anything is 350 CFM going to that coil, right? A little bit different when it's not our equipment because we don't have control over the fan. So once we've taken that total external static, we go to our install manual, service manual of the furnace itself to figure out how do I achieve that. And there'll be charts. It'll say, at 0.5 inches of static, use medium low to get, or medium high to get to, 350 CFM. It will actually kind of break that all down for you. So you just need to, set that airflow.
Let me ask you a question, Brent. When I was in the field checking static pressure just on the coil, I wanted to see what the coil, we talked about the limit switches. I used to take out the little bimetal high limit switch and I put the pitot tube in there. It's just before the evaporator. Right, sure. It bypasses. Is that an acceptable place to measure? Because I don't have to drill a hole anywhere. I'm just going to go right there.
Yep.
Yeah, and if you sit in one of Scott's classes, because he's so knowledgeable about static pressure and everything, and he's getting us all up to speed on this.
Yeah,
that's an option. If you can get in that, that's the perfect spot to check your static pressure.
So I did something right.
Yes.
Yeah. And I think what a lot of contractors do is they don't focus on the whole house. They show up to, a retrofit and they're focused just on the equipment. But you got to look at the whole house. You got to look at the whole ductwork. You got to look at everything. I mean, that could be a whole episode in itself about the envelope of the house. And I would need somebody in here a lot smarter than me to talk about that. But at the very least, you got to look at the whole system. The equipment that moves the air is just a small part of the system. That ductwork is that part of that system, a huge part of that system. Just like, it's just like a human body. If my arteries get all clogged or my airway gets all clogged, I'm not going to get enough air. I'm not going to be happy. So same thing. Well, only different.
Yeah, I mean, it can be a pain in the neck, right? On an install, you already have so much to do. But just remember that a poor installation leads to service calls later.
Right.
So,
well, what's going to be the bigger pain? Dealing with it now before you get an unhappy customer who's going to badmouth you, who's not going to be happy, who's not going to recommend you, and it's always going to have a problem. Because in my experience, when the ductwork is an issue, it never gets fixed. It's always Band-Aids.
Right.
It's always, how do we make this? It never gets fixed. The way to fix the ductwork is from the beginning. You're putting a new system in. Let's look at the whole thing and let's fix the ductwork whenever possible. That Steve's cousin there, I've seen, there's a whole neighborhood in the next town over from here, 2 towns over from here. There's a whole neighborhood where everything comes off the furnaces in the basement. It's all 4-inch, and they squeezed it and put it inside 2x4 walls.
Yeah,
put everywhere. What are you going to do? You can't change that.
Yeah,
and unless they're going to gut the house, then now you need an option. So maybe a Mitsubishi heat pumps are an option for your cousin.
Right, doing something ductless, or just being aware of that when it comes to picking your unit itself. If you already have issues with ductwork, don't pick a low static unit, because we're not going to be able to overcome that, right? There's certain things you can overcome with the equipment. There's some things you just won't be able to. There's no Band-Aid that will be big enough to fix some of these problems.
Right.
So get out ahead of it, deal with it first.
Does your cousin live in Massachusetts?
Yes.
Because the rebates that are out there right now.
Oh, and that's what he's trying to take advantage of.
Yeah.
But I'm trying to remember now if it was 4-inch or 5-inch runs, but I think they're 4-inch. But either way, 5-inch is still on the small side. But it's a very odd setup. And that house was built, I think, in the 50s.
And if I'm a contractor, I'd rather do what you did with your cousin. I'd rather walk away from this job than put something in there that's not going to work.
It's going to be a headache for
happy.
them.
It's going to be a headache forever. I'd rather, because if the competitor comes in and just quotes just the replacement of the equipment and doesn't address the ductwork, and you're obviously going to be higher than that person, you need to explain to that customer, okay, but here's what's going to happen, and here's why I'm higher. And chances are they're going to, okay, that's good, because if the other guy doesn't address this, he's not looking at the whole thing, you're always going to have problems.
Right.
Yep.
Right. Yeah, and I've been in homes where, they were built in the 30s and 40s, and the ductwork was put together with flathead screws.
Yeah.
I can't even imagine. They would drill a hole and with a hand screwdriver put a screw in, and it's leaking everywhere.
Yeah.
I've been in homes where I was actually in a home one time where they had copper ductwork, and it was soldered.
Really?
It was soldered, and it didn't leak. We left it in place, and it was amazing. So know your install, and you may want to think twice about what you're getting yourself into if you have existing ductwork. And especially like in my cousin's situation, his father finished the basement and sheetrocked the ceilings, and all the ductwork's all sealed in. So it's that's
kind of stuck with it.
Yeah, and like you said, maybe ductless units are the answer for that. But yeah, that's an oil-fired furnace, and it's just a big barrel with a flame in it.
You guys were all in the Northeast. I'm sure you guys saw it quite a bit, but the returns that were just between floor joists with some panning.
Yeah.
You ever see those?
Oh, yeah.
That
just
was
a grill cut into the floor and then
that
just
was an
panning
acceptable thing.
going back to the return.
There would be all kinds of wood shavings in there and sawdust and, potato chip bags from the installer.
Yeah, you're using sheetrock walls for plenums and everything else for returns.
Yep.
We put in high wall returns. It's actually a really nice system when you have floor registers and high wall returns like that for a brand new installation.
Yeah.
All right. Anything else we need to know about static pressure?
I don't think so. I mean, it's a lot to think about, and it's kind of tough to do over a podcast.
Let's go back to the SEZ, the little guy. So we're looking at 0.06 static.
Yeah, as your default. It can go down as low as 0.02 and I think as high as 0.1.
And keep in mind, how important is it to have nice round bends on your ductwork? And it's not going to have, like you said, Paul, 48 feet of ductwork. It's not going to work on an SEZ. An SEZ is meant for a 1-room or 2-room the most application.
Right.
And you have to get your ductulator out. You have to account for pressure loss. If you're changing the stock filter, which a lot of people do, and going with a very high MERV filter, you're going to end up with nothing coming out of your outlet, your diffusers at the end of it.
We could do an episode just on manual S and manual D.
And I think we'd get Chris Morin in for that one.
Yeah, because he'd be the guy. But
So hopefully this helps all of you contractors out there in the field. Don't leave that job site without checking your static pressure. Like I said, there are an abundance of amazing tools out in the market now. Measure Quick, Testo, Field Piece, and just countless others that can help you figure out what the static pressure is easily. And don't forget to plug the holes that you drill in the ductwork. Yeah. The little red caps that you can plug.
Yeah, they got the little things that come right with them. It comes with the right size drill bit, and the caps fit right there. And the beautiful thing about that, there's a problem down the road. You can take the measurement again. There's no more drilling.
Yeah. Not only just that, but PMs, right? You got to check delta T across the coil.
Yeah.
You already got your holes.
I can tell you the heat pump that's in my attic, it's a whole house heat pump. It has those things in there from when I installed it, because I did all that. Of course, I don't have any of the tools anymore, and I'm not going up in the attic because my back hurts too much. But
now, a lot of the testing and balancing that I did and Scott has done in the past are mostly commercial and industrial stuff. We're talking high CFM systems. We're traversing ductwork with pitot tubes to check the CFM. We're getting the feet per minute and using some calculations, and a lot of the tools do it for us now.
Yeah.
Back in the day, it would just the tools that I was using in the 90s would give you the feet per minute, and then from there you'd do some calculations to figure out your total CFM. So you're not really using static at that point. You're getting a total CFM in that ductwork, and that gets done on the residential side as well. If you have enough of a plenum, enough area of a plenum to check, you would drill a set of holes across the front of that duct with a pitot tube. You would get all your feet per minute, and there's a certain calculation of how many measurements you get, and that gives you an average CFM, total CFM that you're getting through that system. So that was stuff that Scott and I did. We would use flow hoods back in the day. Flow hoods are not really static would be the way to go in a residential application, but in a large commercial setting with multiple 8-inch diffusers, we would go around with a flow hood and get total static that way too, and do our balancing. What about dampers? We didn't talk about dampers.
Yeah, and it was kind of, started to mention it in the beginning, but yeah, I mean, dampers they're going to affect static pressure. Yeah, especially manual ones, right? And you've got a retrofit with dampers. You want to test them how they're going to be, right? So somebody always leaves a damper partially closed. Like, you got to account for that when you're making your static pressure calculation. So
definitely should install dampers because you're going to want to balance that system out. Right. I'm always in my attic adjusting dampers on my central AC, and my kids are always complaining, "Dad, my room's hot," and so I'm trying to get as much airflow to their rooms.
Balance it out.
They're at the end of the duct, and I get a lot of airflow into my living room and my kitchen, which is not utilized a hell of a lot. We're always in our bedrooms watching TV, whatever. That's where we want to be comfortable in the summer months, so I can control that airflow, cut down on the airflow in those unused areas and push it towards the bedrooms. And I can see the look on Paul's face. He's like, I really don't care if my kids are uncomfortable.
No, I don't. my son said, "Dad, it's really, because," so my son's got the same room he's using when he was a baby. So when he was a baby, I made sure that was the warmest room in the house. Right now, he says it's too hot. I'm not going up in the attic. I'm done. Open a window, whatever. But I'm thinking about your office and my office. Our offices are right next to each other. And if we have a meeting, the offices are 14 by 14, maybe. Yeah. And if we have a meeting, we close the door. I tell you what, this time of year, it's February, you close the door, within about 2 minutes, it's 118 degrees in there, and I'm dying.
Well, it doesn't help that you blocked the ductwork off in your office and it's pushing all the air to mine. So
mine needs to be blocked off more because it still gets really hot. Now, not as hot as yours.
Meanwhile, I'm on the other system, so I'm always freezing. And then I come over to you guys' half of the building, and it's like 10 degrees warmer.
But this is typical. You talk about, what I'm going to call worst practices, right? Yeah. This is typical of a commercial building. Every time a tenant comes in there and walls change. But you know what? The rooftop units that are up on the roof and the ductwork that's on there is the same ductwork it was when they originally designed this building, and it may have been fine for the original use, but then as the walls change and things change, I guarantee you this was one big open area back here, and it's what happens. It's what happens when you don't address the whole system. So address the whole system.
Absolutely.
All right, Scott, if you're listening, you can hammer us later for all the mistakes that we made on this episode. I think we did pretty good. This is actually. All of this information is in our M&P training now, our M&P Essentials class, which we never really talked about static in the past in our courses, but now because of all of the calls that we're getting for underperformance, issues with air handlers and ducted units, we had to put this into the course. And thank you, Scott, for giving us the knowledge that we need to teach it. And awesome.
All right. Thank you, everyone. Take care.
All right. Take care.